Hello class. Today I want to talk about classifying numbers. There are 8 types of numbers that I would like for you to know information about. 4 of the sets of numbers we're fairly familiar with. Natural numbers or counting numbers, whole numbers, integers, and rational numbers. Those are the ones that we've heard of before, but we also need to be familiar with irrational numbers, real numbers, complex numbers, and imaginary numbers. Now for the 8th grade test, we only have to know through real numbers. So let's see if we can look at a few of these definitions and some examples. First off, I want you to know that all these numbers that we're going to talk about, or the number systems that we're going to talk about, are interconnected with each other. So one set builds with the next one. So we've got this one set, and then the next set has all of those plus some more, and then the next set has all of those plus some more, and so on and so forth. So as we're going through that, we're going to refer back to this little chart right here. So the first set of numbers that I want to talk about are the natural numbers, or the counting numbers. Natural numbers are just the numbers that are used for counting, such as 1, 2, 3, 4, and so on. And that is our basic set. Now you'll see some pictures that say the natural numbers are divided into 2 pieces, prime numbers and composite numbers, and they are. All right? So let's look at the next set. The next set is the set of whole numbers. And the set of whole numbers are the natural numbers, or the counting numbers, plus 0. So when we go from our natural numbers right here, we only add one number to get to the whole numbers, and that is the number 0. The next set that we need to look at are the integers. Integers are the set of whole numbers and their opposites. So whole numbers are 0, 1, 2, 3, 4, and 5, and so on. The opposites are the ones that are on the other side of 0. Same distance away from 0, just on the other side. So -1, -2, -3, -4, and so on and so forth. So if I asked you negative or positive 3 right here, what is its opposite? You would say -3. And it's the opposite because it's the same absolute value, okay, which means it's the same distance away from 0, just on the other side of it. Okay, so you'll notice that, again, we had natural numbers, we added a 0 for the whole numbers, and then we added all the negatives for our integers. The next type of number that we're going to deal with are the rational numbers. Now, rational numbers has a rather lengthy definition, but I need you to understand this definition. It says a rational number is any number that can be expressed as the quotient or fraction p over q of 2 integers with the denominator q not equal to 0. Since q may be equal to 1, every integer is a rational number. So if I were to look at this p and q, okay, the p and q idea right here, where p and q are variables that can represent any number. So if I were to take any number and put it in the place of p, such as 15, and I could divide that by any number, like -3, or I could do 15 divided by 4, or any number other than 0, the only number that we cannot use as a denominator will be 0. Okay? You can even use a whole number, because to make that a whole number, or to make that a fraction, you just put a 1 underneath it. So what I really need you to know about for rational numbers is it's any number that can be written as a fraction. So here are some examples of some rational numbers. So 1/2 is a rational number because it can be written as a fraction. 0.75 is a rational number because it's going to be 3/4. Okay, 1 is a rational number because it can be 1 over 1. 2.12 can be a rational number because it can be 212 over 100, or 2 and 1200ths. Even negative numbers are rational numbers. Even though -6.6 is not an integer, it is a rational number. So what I need you to know about rational numbers, it's any number that can be written as a fraction. And you'll notice that when we look back at our chart, that is a big chunk. Okay, so we got naturals, which are just your counting numbers. Whole numbers add a 0. Integers add negatives. Rationals add all those numbers in between whole numbers, like on a number line, when you had the numbers between 1 and 2. Okay, you've got 1.5 and 1.7, 1.07. That makes the rational numbers. But then we've got this other set right here that's kind of off by itself, called an irrational number. Okay, irrational numbers are real numbers that cannot be written as a simple fraction. Okay, so it's a number that can't be written as a fraction. Okay, so in other words, the decimal goes on forever. If you were to type it into the calculator, the decimal will go on forever, and it doesn't actually repeat. It doesn't repeat at all. So if you were to look at pi, which is the most famous irrational number, we get 3.14159, blah, 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 all that kind of stuff. It cannot be written as a ratio. Now, we may have one that is close to that, but it's just not one. In that decimal, there is no pattern of repeating. Okay, so if I were to bring up a calculator here, let me bring up this calculator real fast, bring it into form here, or into the image. If I were to do some math problems, such as, let's say I did 1 divided by 3, and hit enter, I would get the value of 0.33333333 all the way across. Well, that has a pattern of repetition. So that one is a rational number, because there is a form of repeating. But if I did something like the square root of 2, that gives us 0.14 or 1.41421. There's no pattern of repetition here, and it just keeps going forever. The same thing for pi. That is the definition of an irrational number. Okay, so we will have some that they repeat, and if we can see that there is a pattern of repetition, then it's a rational number. If we can't see that there's a pattern of repetition, then more than likely it is an irrational number. Okay, so irrational numbers are kind of off by themselves, but you'll notice that there's one group that encompasses both of those, and that is the real number, the real numbers. Okay, so a real number, something like this. Okay, it says that the type of a number we normally use, such as 1, 15.82, negative 0.1, 3/4, etc. So what a real number really is what this thing is that's underlined. Any number that can be placed on a number line. That is what a real number is. So real numbers are a combination of the rational numbers, any number that can be written as a fraction, and the irrational. Okay, even though I can't write it as a fraction, there is a number that represents it, and it can be placed on a number line, such as pi. Pi starts off with 3.14. Can I put that on a number line? Yes, it's right in between 3 and 4. That's where it's found at. So it can be placed on a number line. Now, the other two sets of numbers that I would like for you just to be familiar with are imaginary numbers and complex numbers. Now, the imaginary numbers are kind of a combination, so they would actually fit like right in here is where the imaginary numbers would be. Okay, because imaginary numbers are kind of a number by themselves, okay? But it's a combination of two sets. Okay, it's a combination of real numbers and complex numbers when we add them, when we put them together. Okay, so imaginary numbers are a number that, when squared, gives a negative result. And I know that's kind of a difficult thing to understand, but if I were to take the square root of -1 and square that, I would get a -1 as an answer. Okay, so that's why the square root of -1 is actually our first imaginary number. I is equal to the square root of -1. Okay, so we won't really deal with imaginary numbers until you get into Algebra 2, but I wanted you to know that they exist. And then, if we take a combination of a real number and an imaginary number and put that together in the form of a plus bi, that makes what we call a complex number. Okay, so those are the sets of numbers that I need you to understand. So we kind of look at it like this. Here are some examples of those numbers, where we've got natural numbers, which are our counting numbers. We add 0 for whole numbers. We add the negatives for our integers. Any number that can be written as a fraction is a rational number. Any number that has a non-repeating, non-terminating decimal is called an irrational number. If we put rationals and irrationals together, we get the real number set. And then we've got the last two that we've been looking at, and that is the complex and imaginary numbers, which is a combination of real numbers and imaginary, and that gives us our complex. So that's what we have. So let's look at a little activity real fast on placing numbers in the proper spot. Okay, so I've got a series of numbers along the bottom of the screen. Like take, for example, number 5. So this 5 here, I can actually pull it out, and this 5 can go in several places. Well, the 5 can be a natural number, but it could also be a whole number. It could also be an integer, and it could be a rational number. It could also be a real number. So that 5 actually fits in all of those different places, and you've got to be able to know what set a number goes into. What about negative 12? Well, will the negative 12 be a natural number? No. Will it be a whole number? No. But it will be an integer. Okay, and if it's an integer, that means it would be a rational and a real. So we would have just those 3. Well, what about pi? Well, pi is one of those that only fits in 2 categories. It would be an irrational, which means it would also be a real number. All right, 6.4, well, it's not going to be natural because it's got a decimal. It's not going to be whole because it's got a decimal. It's not going to be an integer because it has a decimal, but it can be written as a fraction, so it would be rational and real. Okay. 3/4, well, it's a fraction, so we know it can't be one of these first 3, but it will be rational and it will be real. Okay. What about 3 plus I? Well, that's that combination of real and imaginary, which makes it a complex number. Okay. 0, well, it's not a natural number, but it is a whole number, which makes it an integer, which makes it a rational number, which makes it a real number. Negative 4.5, well, it's not natural because it's got a decimal. It's not whole because it's got a decimal. It's not an integer because it's got a decimal, but it is rational. Even though it's negative, you can write that as a fraction, which then makes it a real number as well. Negative 6 starts off as an integer, which then would be a rational, which then would be a real. 8 would be natural because it is a counting number, which makes it a whole number, which makes it an integer, which makes it a rational number, which makes it a real number. So it would be a little bit of everything except for irrational and complex. And then last but not least, we've got the square root of 2. And the square root of 2 would be irrational, which would also make it real. So as you see, numbers can be in multiple sets. Okay, so we have to know the definition well enough to be able to identify what sets a number goes in. Until next time.